In this video, I'm going to set up 3DBenchy for printing directly from from an STL file rather, as downloaded from Thingiverse. So we're starting here before we even get to the printer in software, in Creation Workshop, where I'm going to open and lay out the 3DBenchy STL file. So this is the STL file that I directly downloaded from Thingiverse and that we're going to print pretty much as is here. So I've got the STL file loaded and I've got the scene set up. So let's double check and see how much resin this is going to take. It looks like this volume is 15.51 cubic centimeters. So that's about 15, that's going to be 15.5 milliliters of resin. Now, oftentimes for SLA resin printing, people do suggest that you hollow out your models. And there's two reasons you want to do that. You want to hollow out the model in order to reduce the XY surface area, to reduce the amount of separation forces per layer, and you want to do that in order to save resin. I'm going to take this build relatively conservatively, as we'll see later on in our settings. And so this file, 3DBenchy, is not super huge. I'm not too worried about the horizontal surface area, but I do want to take a look to see how much I might save in resin and how much effort it'll be to hollow out the file. Now, hollowing out the file is relatively easy. If you come into Mesh Mixer, you would open the file and then pick up the hollow tool, which I've done here. And when you open the hollow tool, it'll compute the hollow, and so the ghost area will be solid, and the gray solid area is the hollow that's going to be added. And if I wanted to hollow the model, I would hit accept here. I'm not actually going to do that for this model because in this hollow, I see that it's going to take some more work to get this properly hollowed. You see that there is this depression in the gray area here, right? And actually the solid gray is empty space. And that means that printing from top down, bottom up rather, right? We're going to start in the bottom up. It means that this air wall here at the bottom is going to start building in the middle of thin air. Because it's going to start building lower than the rest of the floor here. I really want to see that this hollow area is completely convex, meaning there's no depressions. And it's pretty convex, but this area, this depression here, is clearly concave. And that's going to give me problems because I'm going to have to build supports to support up the floor here through the hollow. Another problem with this model is that unlike figures, 3DBenchy was designed in CAD, and that means that the mesh density of this file varies a lot from point to point, right? Meaning smooth areas, the mesh density is low, and then the mesh density becomes super high at the corners or where the triangles align exactly. And that is going to create problems when I make drain holes. I can easily make drain holes by simply double clicking wherever I want them to be. So I'll click here and that produces a drain hole, normal with respect to the hole. And then I could try to stuff a drain hole inside of this hole, right? You see that there's a hole here, and I could say, okay, I want to put a drain hole in there, click here, and then this will create a drain hole that kind of connects. I'm going to probably have to reduce the size of these holes if I really wanted it, but it turns out that there's a bunch of steps more I would have to do if I wanted these holes to work, because the mesh density of some of these surfaces is very low, and so there'll be weird side effects from adding these holes because the mesh density won't be high enough on these smooth regions to accommodate the um, holes well. And so you'll see that there's some wrinkling and then some weird things have happened here. In any case, I'm not really going to hollow out this model because this would take a bunch more time. Especially for a model this small, it's not really worth it. Just as comparison, I did hollow it out, and we'll see that the hollowed version is lower in volume. It's only 10.5 cubic centimeters, so it does save me about 5 milliliters, but that 5 milliliters isn't worth, for me at least, the extra time it's going to take to get that hollow working well. So I have this laid out now, and before I go and slice it, I have to make sure that my machine configuration is set properly. And so I go head over to this configure tab, and there's two sub-tabs. There's the machine configuration and the slicing profile. Most of these parameters don't matter. So let's start with the machine configuration. The most important part of the machine configuration is going to be that the configured display is 1920 by 1080. That is the native resolution of the projector that's in the Titan 1. So it's got to be 1920 by 1080 because that's the pixel number of pixels we'll have no matter what. And then there's going to be the build size, all right? And this is going to tell Creation Workshop what the physical area these pixels are mapped to. And the way I recommend measuring these is the Z is always 240 because that's the height of the Z stage. I think we can go higher than this, but I like 240. It's nice and safe. It keeps me a little bit away from the top edge. And then the X and Y, I recommend now measuring this off the calibration grid, which means project the calibration grid into the vat and put a piece of paper into the vat, and then use a pencil, mark off the boundaries of that calibration grid, and then measure those with calipers or the ruler as precisely as possible. And so basically, I projected this into the vat, marked the width and height, and then entered those into the build size here. I mean, I measured the build size optically. I didn't measure the build size based on a real print. And the reason why I recommend doing it this way is actually based on a series of posts on the forum by another one of our early users, T Dixon 1000, and he builds some very accurate engineering models for his engineering and machining business. And in particular, when building models for engineering purposes, you need to make sure that the negative space, the holes, are accurate. And since resin shrinks, if you enter these in or use the adjust button here to get the dimensions based on a printed model, you'll be baking in the shrinkage of the resin in. And that'll be fine for the outer dimensions of a model. So if you have a model which has no negative space, it's purely convex and doesn't have any holes in it, no depressions, then you could use this in order to easily get the outer dimensions as accurate as possible, taking shrink into account. The problem is that shrinkage affects negative space and positive space differently, right? So a sphere is all positive space, whereas a donut has a hole in the middle. There's some negative space. And when you shrink, if I take shrink into account based on the measured outside dimensions, holes will become way, way, way too small. And 3DBenchy has a bunch of holes, so I have moved on to, rather than using calibration directly from prints, I measure it from optically, and then if I need any further adjustments, I can adjust both the exposure time and the model size in order to get the dimensions, both the internal dimensions of holes and the outside dimensions of positive features correct. And so that's where I got the X and Y, just measured off the calibration grid. These other things here mostly don't matter. We don't print directly from Creation Workshop, and so these settings like the port and the mask, they don't apply. If you use these, they'll have no effect. Same thing as user parameters, totally empty, nothing going on here. So the only thing that matters here is that the configured display is 1920 by 1080, and that we have the X, Y, and Z build size set. Z is always 240, that's easy, and then X and Y are set to the size of the grid as measured at the bottom of your vat. Then there is the slicing profile. The Slicing profile also has a whole bunch of parameters that are used when you print from Creation Workshop, but with the Titan 1, we're not going to be printing from Creation Workshop, so there are actually only a small number of parameters that matter. The slice thickness, 0.1 millimeters. This is important. This is how thick the slices are going to be, and this number has to match the layer thickness in the Kudo3D software, which means if you are 0.1 here, then you have to be 0.1 in here. The other things that you'll need is you need to make sure that you have reflect Y turned on. This will flip the image correctly since we're projecting from the bottom of that through. So you'll need to take this into account. You need to reflect Y. And then we need to make sure that our export options are going to export PNG files. And so we have the export to CWS, export to disk settings checked to make sure that we will output the folder that contains the image slices. Now in reality, the most important one is this export to disk, but you'll notice that when I turn off export to CWS, this means am I going to save the slice files in the save file? And if I don't save it to the save file, export to disk becomes grayed out, right? So I have to have export to CWS checked in order for the slices to be output, and then I have to have export to disk turned on also. Both of these need to be checked. The rest of these numbers don't really matter. The rest of these numbers will be used for our purposes to generate this estimated build time. This number is not going to be extremely accurate because we have several different layer settings in the Kudo3D software, whereas in Creation Workshop we only have exposure time for the bottom, exposure time for everything else, the number of bottom layers, and then we only have one set of settings for the lift height, lift speed, etc. Right? We don't have any retraction, we don't have any sliding, and so these settings here are relatively, there's really not enough for it to accurately predict time, since we have several different, we can have several different z-lift speeds and z-lift heights going on. So really, you need to have slice thickness set. This number is going to be the same as in the Kudo3D host software. You need reflect Y set, and then you got to make sure that you have export to CWS, export to disk set, and then you can save this. So these are our two things from configure machine and configure slicing profile. So now we have this laid out. The question is, like, where do we want this on our build plate? When you did the calibration at the printer, say to calibrate the XY resolution using Jens's calibration sheet, you probably noticed that the projector is not in focus to the same degree at every point. And in particular, the projector has best focus in this area here, which means kind of from the center all the way down to what is the bottom of the projected area. Now, when we look at it this way and think about how this is mapped to the vat, this is from the projector's perspective, right? And so when we are looking at this projected view, it's as if our eyes were at the projector looking at the vat. I mean, we're looking at the vat from the underside, right? And that means that the bottom of this area is going to be the right side of the printer looking from the front, right? Because in reality, when we look at the printer, we'll be looking at it from this side because of the orientation. And that means that the best focus area is really kind of from the center working our way down to the bottom of this area. And so I'm going to move the object down a bit, maybe not that far, about here, to try to take advantage of the best focus spot. This is a benchmark object, right? A calibration object. So I might as well try to get the best resolution I can. In reality, if you were printing figures, minions, other things, you won't notice much of a difference. I've printed some pretty big stuff, taking up most of the VAT, and I don't notice a tremendous difference on the edges. So even though it does look fuzzier, it's not going to present a huge change in the appearance of your models on whether it's printed here or printed up here, printed over here. But since I have the ability to print wherever I want, here is as good as any. And then I'm going to save this file. So I'm going to save this as 3DBenchy.cws, and you have to save before you slice. So I'm going to save this file. Now that it's saved, I'm going to slice it. And now we hit slice, and this number will count up, relatively speedy, but this will take a little bit. Okay, and we are reaching the end. Now it's sliced. I can switch to the slice view and take a look at these slices. I can drag here and work my way up. What I'm looking for really is I don't want white areas to appear in the middle of black areas out of the middle of nowhere. White is where I'm going to project, and black means there's empty space. And I don't want to see any solid areas appearing in the middle of nowhere, because that means that I have an unsupported area. Shouldn't have any of those, but you'll see that, okay, this is okay because the white area here was previously supported by here, so we're basically just reducing the surface area a bit. That's no problem. Let's move up. And pretty much the surface area looks pretty good, so I don't have anything. Yeah, so that hole does not appear out of nowhere. It's supported by this area beforehand, so it looks pretty decent. The last piece is the attachment layer. I did not use the Creation Workshop feature for creating an attachment layer, and I'm going to do that manually in Paint. So if I come over into the folder, this is the models folder where I saved the CWS file. In the same folder where I put the CWS file when I click the Save button up here, there should now be a slice folder with the same name. And when I come in here, we've got our slices here. And so here's 0, 1, 2, 3, 4, 5. All right. We don't like this 000 file. Generally speaking, the loss of a 1/10 of a millimeter is not a big difference, not a big deal. And so I usually just delete the 0th file. Alternatively, if you really want to keep that first layer, you would, before slicing, you would raise the model by 0.1, right, by putting it here. Sorry, not in X. You would raise it by 0.1 in Z. And then if you raise it in 0.1 in Z, then it's floating one layer above the surface. One layer because I set it, my slice thickness to 0.1. If this were set to something different, then I would raise it by that amount. And now that it's floating up in midair, that means that 0th layer would have nothing in it when generated. In this case, it doesn't really matter. In most cases, I don't bother with raising it by a small amount. But you can if the precise Z height does matter to you, or if you have something on that first layer that you really want to keep. Now that I have this here, I can open this up in a faster viewer. Fan view is one of my favorites, and I can scroll through this and kind of animate how the layers are going to be built so that I can watch it. I'm just holding down the right arrow key, and so I can watch this to double check to make sure that there is nothing floating up in the middle of nowhere, and everything looks pretty well supported. All right, 300. and then 479. All right. Now I'm going to edit this and put an attachment layer on here. And I usually just do this in Paint. I'm going to use a rounded rectangle. And the way that reason I like doing this is I like to leave some hint on what the wall is to make it easier for me to cut off the edge with a knife. So I'm going to do solid color here, and I'm going to put this here. I'm going to put one over here. Put an edge here. And this will give me, right, have some of the original contour here, so I can like slip a knife in here, then follow it around. And this should be enough to keep the model from peeling up. So I'm going to save this in Paint and then close this. Now this is the directory that I'm going to be printing out of on my printer. Now that we're ready to print, we're going to go and open the Kudo3D host software and then load the model. If we come into the models folder where I have all of these saved, we'll see that the slice directories show up here, and then I can open up any of these images. It doesn't really matter which one you click on, and this will give us the open up the settings here. This projected X here doesn't really matter. What matters is my X is set to 1920, Y is 1080. I'm going to begin at layer number 1, and this layer thickness, remember, has to match the layer thickness that I had set previously in Creation Workshop. This is in millimeters. So quick rehash, 0.1 millimeters, that's 100 microns. If I had sliced at 50 microns, this would be 0.05. This layer thickness is important because we don't want, especially the base layers, to be too thick. If you make a mistake, like set this to 0.5, bad things may happen to your print, especially since then the shrinkage will be significant on the attachment layers. The biggest we want to go generally is if you're doing a draft, you might be able to go down to 250 microns. But generally speaking, I usually print at 100 microns, 0.1 millimeters or less. So I've loaded the model, and we can see here that this is the model file, which is the first number in the first image, and then in the sequence. If I went to load model and picked up the 8th image, it's called 008, but the number of total layers is the same, right? And so you can see here from my opens, no matter which one I opened, it was 479 layers found for a total height of 47.9 millimeters. It's best not to mess with these offsets. This allows you at the last minute to shift the image around on the output. Usually, we don't really want to do that. And so now I've got to set the layer settings. And these layer settings are very important because this is where the exposure settings come from. I generally recommend that you look at, from the downloads page, there's a set of recommended settings and layers for the different resins that Kudo3D recommends. I am going to import one that I created earlier. Come to my notes here. I've got a bunch of these in CSV format, and I'm going to be printing, what am I going to use here? Maker Juice. All right, so this is what I use for my handle. So you'll see that this is somewhat similar. This is closer to the Kudo3D recommended settings, 90, seconds of exposure to start with, and then 25, and then 14, 14, 14 is what I ended up finishing with. Now, the layer settings here only go up to 192 because that's whatever the last thing that I printed. My handle was only 192 layers high. So I'll put like 500 here, and that'll then increase this up to 479. I'm going to double check to make sure that my layers are contiguous. And so I'll do that by unchecking, graying them out, and then bring them back. As I click the pluses here, the software is going to check that there's a contiguous layer, which means let's say I made a mistake, right? So 1 to 1, 2 to 9, 10 to 45. Let's say I set this to 40, right? So now this is messed up because these two layer settings overlap. As I work my way down, right, and then I come back, this is going to automatically correct itself to 46, which is the correct layer to come after 45. And so I do this just to make sure that I don't get any discontiguous layer designation error messages when I print. The next thing I want to look at now is my lift heights. My lift heights are going to be a bit sensitive here because I do have some pretty big surface area parts. If I come back to the slices here and I scroll forward a bit, you'll see that there's this area here is a huge surface area, right? And so I'm up to layer 50 here, and I have some pretty big surface area going from like layer 15, and I don't start to hollow out until I hit, around layer 86, right? And I'm going to want to make sure that I lift enough up to that layer. And so I'm probably going to change a couple of these things here. I'm going to want to take from my attachment layer here is 90, and that's fine. And then my base wall layers I'm going to keep at 25.8, and that'll be fine. And then I'm using 14 seconds of exposure for the rest of the areas, and then I'm gradually lifting less and increasing the speed in order to go faster. But I know that I really want to, I don't hit a nice open area here until I hit layer 86. So I'm going to, from here, go up to layer 86 with bigger and slower lifts. Stay at 7 seconds and then lift more slowly. I'm going to actually be relatively conservative, and so I will dial down these numbers all the way up just to make sure that I don't have something break off. Having conservative lift speed is important because we don't want to lift too fast and then have something break off, either lift up our FEP film or have the part fall off. So we'll go 14, 14, 14, all the way up here. The down speeds are 200 millimeters per minute by default. That's fine. Let me just double check here. From 87 to 120. Let's see what we have here. 87. Whoops. To 120. It's getting smaller. But we don't get really thin until here. We get to around 187. So I'm also then going to stay at the 30 millimeter per minute lift here until I get to around 187. And then only increase to 40 once I get over that. I'm mostly eyeballing this, and this might take some experience for you to look to see how fast you can go. Because of course I could, if I wanted to be really conservative and scared, I could set it to 15 millimeters per minute for the whole duration, but that would be pretty slow. My lifts are actually probably conservative. I probably don't need, at this point, a full 6 millimeters of lift here. I could probably get away with 5 or less. I might even be able to get away with 2, but it's hard to say. I don't want to push it too hard, but I don't want to wait forever. So I'll set it to 5 here. And my up is at 40, which should be okay now at this point. Because from here, from 187 to 479, I'm mostly building this tower and the smokestack part of this boat. And so my area gets progressively smaller and smaller. Right? There's very little actually printing here. No, but actually there's a roof comes in. Where does this roof come in? 366? Now this is pretty small. I think I should be okay. Sometimes if you have a roof coming in a big area, you might want to, again, lift more and then slow down. And actually, I'm a little scared, so I'm going to undo that change I did before. I'll stay at 6 lift just to make sure that that roof doesn't doesn't stick, just to make sure I fully separate when the roof comes in. Sometimes if you have a roof come in and you've printed flat like this, you might want to go and again reduce the upward speed. Alternatively, and something that I didn't do, is another thing you could do in general to really change the dynamics of the model is you could put a base on and do some rotation. For instance, I could put a bit of y-axis rotation here and move it 10 degrees, not that way, this way, and the y-axis. And then I'm going to need to move it back here, right? And so this is going to, this would significantly change the cross-sectional surface areas now that I've kind of rotated this by 10 degrees. But once having done this, I'm going to need support because now only this little edge is touching the bottom. And that means in order to get this to work, I would have to generate supports. And it's a little bit too aggressive. I don't need supports up all of these walls. Right, and then I would also need, I might put in an attachment layer also. But in either case, I wanted to avoid supports. More importantly, one of the interesting things about the Titan 1 is you're not as set, because we don't have silicone on the bottom, because of the way the peeling works, doing this in another printer might require you to prop it up like this. But one of the interesting things that I want to show you is that in the Titan 1, I don't have to do this always. It can be helpful, but for a small part like this, even though I have some big surface area portions, I didn't hollow it, and I also did not prop it up, and I didn't rotate it. I'm going to print it flat, and we're going to see how that works. And so these are the settings I've got here. Just to save them, I'm going to save here, and here I'm going to be maker juice, and then this is going to be 3DBenchy printed at 0.1.csv. These are going to be my draft settings. And then I can do, I want to kind of get a time estimate here. Time estimates here will be more accurate because now I have all of these layers into account. I can do a run here and see that the time estimate, okay, it's a little long, 3 hours and 52 minutes. But that should be okay. I could turn the exposures down a bit maybe on some of these if I wanted to go faster. But since this is the first time I'm printing it, and because I didn't rotate it or anything, I think I'll just let it go for this 353 and see what it looks like. So that's done for my stop. I'm not connected to the projector now. Now I'm ready to go and set up the print.